Hey seniors, today we're going to put together a whole bunch of skills that we've learned over the past few weeks and really focus more on equations, tables, graphs, and remind ourselves what rate of change is. So go ahead on your notes page, go ahead and write our title, which is equations, tables, graphs, rate of change. This is stuff that you guys already know, but I want you guys to write it down again because the more times you write it down, the more likely you are to remember it. Rate of change always refers to my slope in an equation, and my initial value refers to my y-intercept. So if I had y equals 5x plus 10, my initial value here would be 10, which is the y-intercept, and then my rate of change would be 5. Let's go ahead and jump into an example. Remember, you only need to write what I tell you to write. All right, guys, let's go ahead and look at this one. You need to have example 1 written on your notes page, and then this little mini table written as well. You do not need to write the words. Stretch has decided to work out and get into shape for basketball season. When she begins her workout, she is completely cold and hasn't sweat at all. After 3 minutes, she wipes 6 beads of sweat off her forehead. After 6 minutes, she wipes 12 beads of sweat off. Assuming she is sweating at a constant rate, write an equation for the scenario, graph it, and find the rate of change. All right, the first thing I need to do is go ahead and fill out this table. I'm given a whole bunch of numbers. The first thing I'm told is when she begins her workout, she's completely cold and hasn't sweat at all. If she hasn't worked out at all, if she's worked out 0 minutes, she's sweat 0 beads of sweat. Those are going to be my first values in my table. After 3 minutes, I can go ahead and fill in 3. She wipes 6 beads of sweat off her forehead. So that tells me after 3 minutes, she's sweat 6 beads. After 6 minutes, she wipes 12 beads of sweat off. Now, all I have to do here, since I have my table filled out, is that assuming that she's sweating at a constant rate, I can go ahead and write an equation. And the way that I do that from a table is change in y over change in x. So it's going to be 6 minus 0 over 3 minus 0. Now, 6 minus 0 is going to leave me with 6, and 6 minus 3 is going to leave me with 3. So I have 6 divided by 3. 6 divided by 3 is going to leave me with 2. So I have a slope here of 2 throughout. So I have half of my equation already. Now I just need to figure out what my y-intercept is. My y-intercept is always where x is 0. The value of y is my y-intercept. So my starting point would be 0 in this case. Let's go ahead and graph our equation. Okay, guys, if our equation is y equals 2x plus 0, y represents the total amount that she has sweat. So I'm just going to label my y-axis with sweat. And x represents the total number of minutes she's worked out. So our slope is going to represent sweat per number of minutes. Now, if I want to graph this, it's a normal graphing procedure. All I have to do is start with my y-intercept, which is 0. If I have a slope here of 2, that means I'm going to go up 2 and over 1. And up 2 and over 1. Up 2, over 1. This is the same as rise over run. Up 2, right 1. Up 2, right 1. So again, you see that I'm getting a perfectly straight line. And the slope of my line represents, again, sweat per minutes worked out. Okay, guys, let's try example 2. I'm going to go ahead and read it. Again, you only need to write the numbers in our table. Bailey is preparing for the Olympic trials. In 1 minute, she can swim 1/6 of the length of the pool. In 2 minutes, she can swim 2/6 of the length of the pool. Assuming she is swimming at a constant rate, write an equation and graph it. And we also need to identify what the rate of change and the initial value is. Well, let me go ahead and put some of this information into a table. If Bailey has not swam at all, if she has swum for 0 minutes, she has swum 0 lengths of the pool. So that's going to be my first values. In 1 minute, she can swim 1/6. I'm going to put that into my table. In 2 minutes, she can swim 2/6 of the length of the pool, which is the same as 1/3 if I reduce that. Now, what I want to do here is go ahead and write an equation. And of course, I go back to change in y over change in x. So it becomes 1/6 minus 0 over 1 minus 0, which is the same as 1/6 divided by 1, or just having a slope of 1/6. So my equation becomes y equals 1/6 x. Don't forget your x value, otherwise it's wrong. And then my initial value, or my y-intercept, wherever x is 0, the value of y is my y-intercept. And since if she hasn't swum any lengths to the pool, my starting point has to be 0. Alright, let's go ahead and graph that. Alright guys, let's go ahead and graph this equation. I have a blank graph here, which means I need to label my axis, and my x-axis was minutes. I'm going to go ahead and label that. My y-axis was lengths of the pool. And of course, I know my starting point is 0, so I'm going to go ahead and put a dot there. Now, if I have a slope here of 1/6, that means I'm going to go up 1 and over 6. 1, 2, 3, 4, 5, 6. And then up 1 and over 6. 1, 2, 3, 4, 5, 6. Up 1, over 6. 1, 2, 3, 4, 5, 6. Again, it's not a very steep line, but it is still a straight line because she isn't swimming super, super fast. Now, my last thing I need to do here is identify what my rate of change was and also my initial value. Well, if I look at my equation, y equals 1/6 x plus 0. 0 is going to be my initial value. That's my starting point, or my y-intercept. And 1/6 will be my rate of change. Alright guys, that's going to be it for me today. You guys are going to see fractions on your practice and on your prove it. Let's not freak out about them. Let's just approach them from the same manner. And let's go ahead and practice.